Our next speaker is Stefan Prodan. Thank you for being with us, and amazing to also have a core maintainer part of the presenters today. Oh. So give it up for Stefan.
Hi everyone, welcome. I'm very happy to be here. The first ever Kubernetes days in Romania. It's exciting. A little bit about me. I'm an open source engineer. I've been involved into CNCF projects since 7 years ago now. I'm a maintainer of the Flux CD project, which is a graduated CNCF. If you don't know about Flux, it was the tool that sparked the GitOps movement many years ago. And yeah, we are still running it and keep evolving it. But today I'm not going to talk about Flux, I'm going to talk about something else. A tool that I started developing around 1 year and a half ago. It's called Timoni, and it's something that can change the way we think about continuous delivery on Kubernetes. And it's something that I hope at some point will rival Helm and Kustomize, and hopefully you'll have a third option when you want to do, app compositions, app deployments, lifecycle management, and all the good things that you expect from a continuous delivery system. Okay, so who is Timoni for? I split here the user base in two categories. One are software makers. These are, let's say, organizations, software vendors that want to give you a package. Let's say I'm producing a database and you are buying this database from me, this solution, and I want to give you a package so you can install it on your own Kubernetes clusters. It's also about open source maintainers, like all the CNCF projects, right? We need to distribute our project to your own infrastructure, and you need to, be able to reuse a package. Don't worry about it. Just run a single command, and I don't know, Istio spins off or whatever, right? So Timoni is first of all for software makers, and the other part of the user base are Kubernetes users, which they want to easily deploy things, operate them at scale, and don't worry about breaking changes, being able to roll back easily infrastructure, the hard stuff that every Kubernetes operator out here is dealing with on a day-to-day basis. What is Timoni? It's a command line tool for now. It works on any operating system, is a single binary, is written in Go, and is built upon 3 major technologies. One is QLang, and I'm going to talk a little bit next what QLang is. The second one is Open Container Initiative Specification. If you don't know what Open Container Initiative is, it's a specification for how you can store binaries, configuration, anything you want in a container registry. So container registries started with Docker. You are used to store there your app containers. But in the last years, the OCI movement came up with this concept of an OCI artifact, which can store anything, not only your container image that containerd or Docker has to run. You can store there, for example, Kubernetes configuration. You can store there Helm charts, and you can store there the packages that Timoni creates. And lastly, Timoni relies on Kubernetes API, and here the major difference from other technologies out there like Helm and and other appliers, Argo and so on, is the fact that Timoni heavily relies on Kubernetes server-side apply. And that means, for example, when you want to deploy an application made out of hundreds, thousands of Kubernetes objects, Timoni will figure out exactly what object has changed and only perform the change for that particular object. So at scale, you can have these huge deployments, and Timoni will be very efficient with your Kubernetes cluster, and will only drive changes to the things that are actually needed, not just bulk apply everything and hopefully something will change. Going back to Qlang, has anyone here heard about Qlang or wrote something in Qlang? Okay, it's awesome. Yeah, so Qlang is not a general programming language. It's a configuration language. It's built for you to generate configs. It looks like JSON, is a superset of JSON, and it comes with one major advantage. It allows you to add comments to the JSON format. So don't worry, comments will be there. You're not losing them. What's really cool about Q is the fact that as a language, it's not tied to any kind of technology. Q can be used to generate configuration for your routers, for your firewalls, for your Kubernetes clusters, for your Nginx configuration, anything. The idea behind this is that you write all your configuration in this language that comes with built-in validation, immutability, and a bunch of features that allow you to, generate complex configuration without losing your mind. That's what Q does best. But like all good things, it also needs some investment from your part. You'll not be able to write Qlang in and generate Kubernetes configuration in, I don't know, one day. You need to invest a little bit of time because it's a language. It has, I don't know, conditional statements. It has schemas built into the language and so on. So if you are getting started with Q, give it some time. It's not something you can't jump from Helm templating, mixing, YAMLs with variables or bash templating to something like Q. It takes a little bit of time to learn it. And on the Timoni SH website, I have created a Get Started guide. You can follow that, where I'm showing you how to get started with Qlang to generate Kubernetes YAML. As I said, it can generate anything, so it's quite complex. Okay, moving forward. Timoni features, like what do you expect from a package manager? Usually, if we think about package managers, but for operating systems, like Homebrew, apt, and so on, a package manager is something that bundles software and then also manages the life cycle of that software on your infrastructure, right? So Timoni tries to cover from I'm calling it app, but it can be anything that deploys on Kubernetes, from definition, distribution, composition, and lifecycle management. And we'll go a little bit through these features and talk about them. So for vendors or open source maintainers, people that are creating software and they want to distribute it, there are two major features in Timoni which allows you to do that. One is the app definition part, how you write your Kubernetes configuration, and how you do it better than what we have today, right? What we have today is, for example, with Helm, you have a text template-based system. Helm does not understand that when you template something, in there is a Kubernetes object. It's a text file. It happens to have some YAML. Then with logic and with With string substitution, you make that YAML in the final form. With Timoni and Kulang, the whole experience is very different. Timoni is aware that you are templating a Kubernetes object, and you have to tell it, hey, now I'm templating a Kubernetes deployment, and Timoni will tell you if you are making mistakes while you write it. Why? Because Timoni takes the whole Kubernetes schema and looks at the schema and compares what you are templating with the actual schema from Kubernetes. So it's like doing a kubectl apply dry run all the time, but you don't need the server, and it's right there built into the tool. And I'm calling this type-safe Kubernetes templates. The second part is around distribution to container registries. So let's see what it takes to write a distributable application with Timoni. There is this concept of a Timoni module. So it's like, if you want, like a Helm chart. And a Timoni module has this structure, which if you have, who here has written Helm charts? Okay. So this should look quite familiar. You have a template, you have some values, you have an ignore file. The biggest difference between how you write a Helm chart and how you write a Timoni module is that qmod directory, which contains all these schemas that I'm telling you about, that makes the templating type safe, and not only the templating, but also how your users are going to use modules. So this validation expands to when you write it, when you develop it, but also when you apply it and you configure it. So basically, you create this kind of structure, and then you can define the configuration values. And there's a major difference between how Helm or Kustomize or other tools are dealing with configuration values and how Timoni and Kulang does it. Kulang as a language implies and forces immutability on fields. So let's say you have a deployment, and in there you have replicas, and you set the replicas in the template, 3. Later on, with Kustomize, for example, you can say, I'm patching this deployment, and I'm changing the replicas from 3 to 5. And in another overlay, you are changing it again, and so on, right? Then when you end up deploying that thing, you don't know where exactly does the replica value comes from, which overlay, so it's quite complicated. You need to figure out where that value is set, and debugging such a thing is quite atrocious. Also in Helm, you have all these if conditions, right? You can say, oh, if this thing changed the replica here, but later on you can have some other helper that changes the replicas again, and so on. In Q, once you set a field value, you can't change it anymore. So this looks quite terrifying, right? Like, how can I use this language if I can't change things? Well, it has these concepts of defaults, and that's it. So you can set a default for replicas, but then the end user has to set it to a different value. So you have, conceptually, if you think about it, it simplifies the whole procedure around how you debug templates, because you know that once a field is set, it can't be changed anymore. So it's hard. It's not like you can't just migrate from a Helm chart to a Timoni module, because you need a different mindset. But trust me, this immutability feature actually helps you with maintaining modules on the long run, makes maintenance burden less of a burden. Okay, so we have the concept of modules, how we work with modules. So Timoni has a bunch of commands, the CLI, that allows you to create a module from scratch, and it gives you a good structure. It gives you some good examples of how you can get started with it. It also has things for validation and debugging, because I've been writing Helm charts for a very long time, right? Flux has a Helm controller. In the last 7 years, I've been very involved into working with Helm. And I think one of the things that I miss the most is the developer experience part, where I want, while I'm developing a Helm chart, or in the case Timoni module, I want to be able to quickly validate everything. I want to build it. I want to switch values and so on. So Timoni has all these functions in the CLI that gives you a better developer experience for modules. And one of the things that I want to highlight here is this command that's called Timoni mod vendor CRDs. So the idea is, everybody knows that, right? This is where Kubernetes is going. You'll be running tens of controllers, hundreds of CRDs, right? And you need to create custom resources for those. And you want to make sure that when you add, let's say, I don't know, a Tecton task or something like that to your module, and you want to distribute that, that custom resource, you want to make sure that whatever you are templating in there will not fail at apply time, is conformant with the Tecton API specification. So what Timoni can do, you can point Timoni to a custom resource definition, let's say to the Tecton Git repo, or even to your cluster where you have there a CRD, and tell Timoni, hey, import these schemas into the module, so then when you create custom resources, when you template them, Timoni is aware of them and can help you with validation, gives you auto-completion and all the good things. Okay, how do you distribute modules? So there is a push command for Timoni, which is very, very similar to a Docker push command. In your CI pipeline, you'll be building your app. You'll push the app container to your container registry. Then in there, in your application repository, you'll also have your Timoni module. And you can push the module to the same registry. What this means is that you are now using the container registry for both binaries, application code, and also configuration. And you can, Timoni allows you to sign the artifact with cosign, so you can have a better security stance. When you distribute something, you sign all these artifacts that are ending on your users' clusters with the same keys. It comes from the same place, and so on. And you can do things like, listing all the versions from the container registry, find out what versions are available, and so on. So it's very, very similar to the Docker CLI, this part of Timoni. Okay, now for the lifecycle part, right? I know how to write my modules. I push my modules to the container registry. Now, how do I, as a Kubernetes operator, how do I use Timoni to deploy all things? And there are two major features here in Timoni. It's about app composition and lifecycle. App composition is something that is highly needed when you are doing continuous delivery. The thing is with, microservices. Everybody is doing microservices, or everybody is doing microservices the wrong way. They are microservices, but in fact they are a monolith, and you have to deploy all things together at the exact versions, or they will, not match each other. Like, that's very bad. Anyway, everybody's doing it. The idea is you need a tool that can bundle together multiple applications and have a consistent configuration for all of them. So you can reuse values from one application to another. You can pin all these applications to certain versions that you know that are working together, and so on. And this is the composition part. We'll get to the lifecycle in an instant. So for the composition, Timoni has this concept of a bundle. I think in the Helm by default does not have this thing, but there is a project called Helm file. Maybe some of you have heard of it. It's, let's say, similar to that in a way. It's also my inspiration for building this bundle was, in fact, Docker Compose. But the idea is you have multiple modules. Let's say how you install Redis. Well, it's not Redis, it's Valky now. Okay, I have to modify this, yeah. So how you deploy the proprietary fork of Valky, Redis. Then you deploy your application, right? So in this example, basically I want to reuse the password. When I spin up Redis, I need to set up the password for it, and then I want to pass the password to my app config. So there is this concept of, in Timoni, of runtime values, where instead of hard coding here the password and committing this file to Git, and that's very bad, instead of doing that, you tell Timoni, hey, you should get the Redis password from the environment. That can be an environment variable, or that can be a Kubernetes secret in the target cluster. So Timoni will query a Kubernetes object, can be a secret, can be a custom resource, whatever, extract the values that you need from there, and then use that value to configure all these, let's say, components of my application, which is a database and an app. So this is how you compose things, and then you send values that are known at runtime. The runtime thing is quite important, because usually in the GitOps world, we tell people, like, all the things that you use for your app configuration should be stored in your Git repo, right? That's the whole idea. You have the desired state is there in the repo, but there are special types of configuration values which are maybe only known at runtime. Maybe you have some controller that generates a TLS secret. You don't want to get that secret from the cluster, put it in your Git repo, and encrypt it there. Of course you can do it. Flux allows you to, Argo allows you to, everybody allows it. But it's a major complication, right? What if that controller rotates the secret? Then what you have in Git is a disconnect and so on, right? So with Timoni, I'm trying to change things, and basically you have these runtime values that are resolved at apply time. So when you tell Timoni, hey, apply this bundle on the cluster, it will resolve all the runtime values by being able to query the cluster, or your environment variables if you are running this from a CI worker. Okay, what kind of operations you can do with bundles? You can validate them, so before you do any apply, you'll know that the values that you've set to the modules are not according to the schema. So that's the major plus of Qlang and Timoni. Compared to Helm values in Timoni, the values can be validated before you deploy things. You can build a bundle and see all the resulting YAMLs. You can also build a runtime and query the cluster and get all the things and verify them that, okay, the runtime values are actually there. And you can apply the bundle. And compared to other tools, there is a thing here called dry run diff. It's something similar to kubectl apply diff, where you want to say, hey, I'm moving from one version to another. How will my cluster change? Without actually running that command on the cluster and change the state. And this is what the diff functionality does. It uses a Kubernetes server-side apply diff. It takes only the fields that have changed, and then it will give you a summary of all the things that will be changed on the cluster without actually changing them. And you can have a status to see how your application have been deployed, of course, a delete. And because bundles are, other Q files that you store in your Git repo, you can also package those and push them to a container registry. So you can actually run your whole production pipeline by just never look at Git, but look at the container registry that can contain now your app binaries, your container images, your Timoni modules, and also your composition, which are Timoni bundles. You can also do multi-cluster deployments and have logic inside your bundle based on, let's say, your cluster name or your cluster group, and you can define how many environments you want. The idea here is that with Kustomize, for example, if you have 10 clusters, you need 10 customized overlays to set the values for each cluster and so on, right? So it becomes very, very heavy. You have a bunch of files, you have to look everywhere. Here is the actual reverse. You query the cluster before you apply the bundle, and you ask the cluster, hey, who are you? And the cluster will say, I'm the production cluster in this region. And then in the logic of your values, you can say, oh, if this is production, I need to have these values. And if it's this region, I need to set up, for example, this DNS domain and so on. So it allows you to, configure an application based on the target cluster. Okay, Timoni versus Helm, I mentioned a bunch of things. One of the things that I really like about how Timoni turned out is around performance, and mainly due to the server-side apply thing. If you, let's say, run Helm upgrade in a loop 100 times on your cluster, and you look at how much memory your Kubernetes API is using to actually actuate those 100 upgrades, and you do the same in Timoni, you'll see like huge differences, like huge differences. And there are many other differences here. There is a dedicated page for a Helm comparison. And yeah, going back to where I started with Flux, I've built the Flux distribution as a Timoni module. It's called Flux.io. It does a bunch of things. It can deploy Flux at the edge where you have no CNI, no nothing, bare metal clusters, and Flux then can set up the whole thing for you. So this is how a bundle look when you want to deploy Flux along with cluster add-ons. Another thing that people were telling me when I started with Timoni, but we can't renounce our Helm charts. We can't overnight rewrite all the Helm charts that we have and switch to Timoni. How can we graduate? How can we gradually do that switch? And the solution I have for you is Flux Helm release. If you want to orchestrate Helm release deployments with Timoni, there are special modules made for Flux where you can actually instantiate Helm releases there. So you can gradually move if you want to. Resources, there is a Timoni SH website, installation guide. Give me a star if you like the project. How to contribute. I think the most important thing for getting Timoni adoption is people trying to translate Helm charts and then come back to me and say, I have this issue, I have this UX problem, how can we improve it? So that's my message to you. Try it out. Try to port your easiest, simplest Helm chart that you have in your infrastructure to a Timoni module, and give me feedback, see how that is going. Okay, thank you very much. Do I have time for demo? Okay, I'm going to do like a really fast demo, just showing you how. Okay, so I have a Flux.io bundle that I've shown you before. I'm applying this. I have a Kubernetes cluster, has nothing on it, and it will deploy Flux. Then it will configure Flux to deploy Cilium and metric server on that cluster. So hopefully the internet will be good. And this is how it looks like. So it it told me, hey, I have applied all the custom resources of Flux, namespace, resource quota. Flux is now ready, so Timoni also does automatically health checks. Then it has created the Flux Git repository and customization, which configures Flux now to deploy the cluster items, which are Cilium. And deploying Cilium will take a couple of minutes. We don't have to wait for it. But to give you an idea how the CLI output looks like, and you have this type of more colorful output than the usual CLI. Yeah, so that's it. Thank you very much, and yeah, please try Timoni if you have time for it. Thank you.